Hello friends, welcome back to our channel. So today we'll see one more concept in discrete mathematics, that is inference theory in statement calculus. So far we have seen what is a proposition, what is a proposition logic, what is a formula, and what is a well-formed formula, and different normal forms in order to simplify the complete formulas and all these things. And now we'll see the inference rules or inference theory of statement calculus. So let's start the session. Inference theory of statement calculus. So before going to this inference theory, so this inference theory is nothing but the complete rules. So we have seen different laws of logic, right? So similar to that, we are also having some inference rules and the importance of these inference rules. So before going to this one, so let me introduce once again about the statement calculus. So we have studied that the complete problem will be in a form of a case study. A story will be narrated, and from that story we are supposed to define the propositions, and from the propositions we have to define the formula by using the connectives, right? So that we are calling it as a statements or a statement formula. So all such together we call it as a statement calculus. Now the complete case study where we'll be having the different statements or the story is being narrated is called as argument. So that means argument is a paragraph. We can simply, in order to simplify, in order to make you understand, we can say argument will be some story narrated, and from these arguments we'll be having statements. Statement 1, statement 2, statement 3. So different statements will be there. Statement n. Okay, so there will be different statements, and we have to connect these statements using connectives. We have seen different connectives, and or implies, double implies, and all these are connectives. And by forming this one, what we'll be getting? We'll be getting formula. Statement formula. So which we call it as a statement formula. And these statements we are calling it as a propositions. Now in this one, so what is these statements, we'll be calling it as, see for example, not this one. So these statements we calling it as premises. All these statements will be premises, and the last statement, okay, which gives some conclusion, right? So for every argument there will be some conclusion, right? So the story will be narrated. After narration of the story, final conclusion will be there. So that conclusion, the final statement, so let it be a final statement in the argument. So this we call it as a conclusion, right? So two additional terms we are learning, that is a premises and the conclusion. So conclusion is the last statement in the argument, and premises means other than the conclusion, all the remaining statements comes under the premises. Now we have to derive the conclusion from all these premises. So two terms we have seen, one is premises, another one is conclusion, right? So this should be derived from all premises. That means whatever the arguments we are giving, whatever the statements we have done in the argument, from those, based upon those statements, we have to derive this conclusion. So premises means all statements in the argument. Now you might be understanding the difference between the premises and conclusion, right? So this all together we call it as a statement calculus, because this is completely statements. Okay, now inference theory, or we can also say that as inference rules. So we are using these inference rules to derive the conclusion with the help of the premises. So for a case study or for a problem, we'll be having the premises and the conclusion. So we are supposed to prove the conclusion. So that means we have to derive the conclusion from the premises given. So during this derivation of conclusion, we are going to use these inference rules. So we'll be seeing the examples in our next session. In today's session, we'll see what are those inference rules which are being used to derive the conclusion from the given premises. Hope you got an idea about the complete overview of the statement calculus, arguments, premises, conclusion, and all these things. Right? Now we'll see the inference rules. So there are a lot of inference rules similar to our laws of logic. So we have defined the laws of logic in order to find the logical equivalence. In order to find the logical equivalence, we have seen a different laws of logic. But here, in order to derive the conclusion, we are going to use the inference rules. So the rule 1, inference rules. So first rule is modus ponens. So what is the modus ponens rule? Modus ponens rule is if the premises are P implies Q, comma P, then the conclusion, see conclusion always, the conclusion is usually represented with 3 dots. So usually we are calling it as a therefore. Okay, so in a normal English while we are writing something else, so in the examination or in any notebook, we'll be using this symbol as a therefore. Therefore means conclusion. Therefore means a conclusion. So that means by using these inference rules, we are going to prove the logic. Okay, it's a logical proof. We are saying it is a logical proof. So if the premises are P implies Q, comma P, okay, P implies Q, comma P, then the conclusion will be Q. So similar to our laws of logic, if you are having any premises in the form of P implies Q and P, simply we can eliminate that, and that can be written with the formula Q. Okay, so this implies a conclusion. The conclusion will be Q. And the next one, modus tollens. Modus tollens. The rules names are different. Okay, so like associativity, identity, distributive law, De Morgan's law. So here we are calling them as a inference theory or inference rules. So these are the formulas. So if the premises are in the format P implies Q and negation Q, so if they are in the format of P implies Q and negation Q, the conclusion will be negation P. So you can simply replace these two things with a negation P. Okay, next, hypothetical syllogism. Hypothetical syllogism. Hypothetical syllogism. If the premises are in the format of P or P implies Q and Q implies R, if the formulas are in this format, the conclusion will be P implies R. So this is the formula. So whenever if you are while deriving the conclusion from the premises, if you got any two premises in this format, simply you can write the conclusion as P implies R. Okay, in such a way we have to use these inference rules. Now next one, disjunctive syllogism. Disjunctive syllogism. Disjunctive means or, right? So if the premises are in the format of P or Q and a negation P, then the conclusion will be Q. So if any premises are in this format, simply we can conclude them with Q. Next, addition. So we know addition is nothing but a disjunctive connective, right? If the premise is in the format of P, then that can be written as P or Q. Simple addition, simple. Okay, if there is any premises, that can be written as P or Q. So which is a P. And the next one is simplification. Simplification. So what is this simplification? If the premise is in the format of P and Q, if the premise is in the format of P and Q, then the conclusion will be either P. Okay, either P or either Q. Anything. You can consider either P or either Q. So if the premise is in this format, you can conclude it as either P or Q. Next, conjunctive. Conjunctive means end, right? If the premises are in this format P or Q, the conclusion will be P and Q. Okay, conjunctive. So if the premises are P and Q, P, Q, then the conclusion will be either P and Q. So once again I am repeating, this symbol is for conclusion, right? Conclusion. If the premises are in this format, we can conclude that with this format. Next, resolution. Resolution. So if the premises are in this format P or Q, comma negation P or R. If the premises are in this format P or Q, comma negation P or R, then the conclusion will be Q or R. Then the conclusion will be Q or R. P or Q, comma negation P or R, the conclusion will be Q or R. And the next one, exportation. Exportation. So these are the different rule names. Okay, exportation. So if the premises are in this format P and Q implies R, then the conclusion can be P implies Q implies R. P and Q implies R, then the conclusion can be P implies Q implies R. This is an exportation. So once again I am repeating these few inference rules: modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, addition, simplification, conjunctive, resolution, exportation. Okay, and a few more are there. I'll repeat them also. Next, constructive dilemma. Constructive dilemma. Constructive dilemma. If the premises are in this format P or Q and P implies Q and R implies yes, comma P or R. It's two formulas. P implies Q and R implies yes, comma P or R. So two premises. If there are in the format of two premises, then the result will be, the conclusion will be Q or S. Q or S. That is called as a constructive dilemma. Okay, if the premises are in this format, then the conclusion will be Q or S. The next one is a destructive dilemma. Destructive dilemma. Here also, if the premises are in this format, P implies Q and R implies yes, comma negation Q or negation yes. So here P or R, now negation Q or negation Q or negation yes, then the conclusion will be negation P or negation R. Negation P or negation R. Okay, constructive dilemma, destructive dilemma. So here both the information. So P implies Q and R implies yes, comma P or R, then it will be Q or S. P or implies Q and R implies yes, negation Q or negation yes, which gives negation P or negation R. Okay, so these are all the inference rules. Apart from these inference rules, there are a few more inference rules, three more inference rules, that is a rule P, rule T and rule CP. Now we'll see what is a rule P, rule T and rule CP. So just we have to remember all these inference rules, because so by using these inference rules only we are going to derive the conclusion from the given premises. Okay, now the next one is rule P. Rule P means while deriving the conclusion, we can introduce any premises directly into the derivation. So this is nothing but introducing any premise at any point of derivation. So that means, so we'll be giving a few premises, and from those premises we are going to derive the conclusion. So for that, at any point of time, during in the derivation, we can introduce the premises. That means we can get an existing premise. Okay, we can directly get the existing premise. So for better understanding, I am writing here. So getting existing premise, already the premise is available in the derivation. Rule T. What is meant by rule T? So here a new formula will be derived from the existing premises. Okay, a new formula will be derived. So a new formula will be introduced in the derivation, which is formed with existing premises. So from the existing premises, if you are deriving a new formula from the existing premises, if you are deriving the new formula with the help of inference rules, so that is called a rule T. Okay, both are important. And the last one, rule CP, so which can also be called as conditional proof. So what is this rule? If S is derived from R and other premises then R implies S can be derived from premises alone. Simple thing. So this is an additional rule, which is rule CP. So this is only helpful if the conclusion is having the conditional symbol. If the conclusion is having the conditional symbol, so you can derive yes, that means RHS of this formula from the LHS and other premises. Okay, so consider this as LHS and RHS. So if the condition is like this way, LHS implies RHS. So if the conclusion is in this format, so if you are deriving this RHS with the help of LHS and the existing premises, okay, so we'll be considering LHS and other premises, and we have to derive the RHS that implies R implies yes can be derived from premises alone. So the conclusion is correct. So that's a valid conclusion. Okay, and this can also be done in two ways. One is deriving the conclusion with the help of inference rules, and also we can check whether it is a valid conclusion or not with the help of a truth table also. So we'll see those things in our next session. So these are all the different inference rules. One time, I mean, once again, I'm repeating the same thing. The main reason of using these inference rules means in order to derive the conclusion. So for any argument, for any case study, there will be a group of statements, and obviously the last statement will be the conclusion and the remaining statements will be the premises. And finally we have to prove that from the premises, that means from the existing statements, the conclusion is a valid conclusion. That means the last statement in the argument is a valid argument. So in order to derive that conclusion from the premises, we are going to use these inference rules. So all the inference rules which we have discussed just now, just we have to remember, and we have to derive the conclusion with the help of that inference rules, as well as rule P, rule T, and rule CP. So in our next session, we'll see a few examples which follows the rule P, rule T, and rule CP, and how the conclusion can be derived from the premises by using these inference rules. Right? Just go through the inference rules and remember all those inference rules. And not only the inference rules, will be using also the laws of logic, which we have discussed in our previous sessions. So I'll post the link of previous sessions in the description so that you just follow that one, and make sure that you are good at laws of the logic and the inference rules so that you can derive any conclusion from any kind of premises. Right? So I'll stop here, and if you are having any queries or doubts, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. So thanks for watching. Thank you very much.